All right, so welcome everyone to the October 24th OMR Architecture Meeting. Um, so today, there's only one topic that I wanted to bring up today. It's something that I've been working on as an extremely low priority background process for probably a couple of years. So it's that low priority that it's making that slow of a progress. But I wanted to at least raise the topic here and share some information about what it is that I'm doing because it certainly does affect a large part of the compiler component of OMR and other downstream projects. And just wanted to make sure that everyone's aware of what's going on, and obviously to get any input or feedback from you. So I'm not really at the point where I'm sharing code yet. I'm just going to be sharing some ideas that I've been sort of prototyping and measuring and that to see how we can potentially improve things here. And so obviously I'm going to be motivating that going forward. So page. Okay, so what do I mean by tracing and logging? So I'm hopefully never gonna use the words tracing and logging again in this presentation. I just use TL, so just to keep things short. But it's really the interfaces and mechanisms for providing internal compiler diagnostic information during method compilation. So these are the interfaces that people use, the APIs that they use for writing information to the log file, and doing other kinds of services like that. It isn't yet about like how do you change the way that you're printing the encoding for an instruction. It's not stuff like that just yet, but it's really about those sorts of things. And I'll tell you why I'm looking at this in just a moment. So for these kinds of features, they should be used under the control of various trace options like trace full, trace cogen, trace inlining, many kinds of trace options. And I say ideally here because as I've been going through this, and you probably see if you ever generate a log file, that there's a lot of stuff in there that you didn't ask for. And it's because we have a lot of tracing code that actually ends up there without that's not guarded by any particular option. So ideally, it shouldn't be there, but it is. And the destination of tracing and logging is a formatted text file. So we call that the log file. Um, right now, happily, it's in plain text. If you happen to use older versions of some of the J9 technology, you'll find that it's actually an encrypted log file, which makes things a bit of a pain to decode. You have to find the right key first. But there's good reasons for having it encrypted, and thankfully we don't have those reasons anymore, so it's a nice flat text file. Um, this also does include verbose logging, but I'm not going to be talking too much about that at all today. I think that the non-verbose part of things is really something that I want to address first. And eventually, I think we're going to get to verbose logging and maybe making some changes there. But the main thing is anything that we do to improve tracing and logging, I don't want it to preclude it being used in verbose logging down the road. So I'm not planning on touching that just yet. And of course, given my current pace, it'll probably be 2 years before I get to that. So um, anyway, so most of the logic that I'm talking about is into the RAS directory. But as you've undoubtedly seen, if you spent any time in the JIT code, it happens to be sprinkled all over the place. But most of it is concentrated in the RAS directory. And the tracing and logging infrastructure has been around since the very earliest days of the Testarossa compiler technology. So that's 25 years now. And a lot of it was actually architected at a time when tracing and logging wasn't really given any, it was sort of seen as something that you might have to do. It's given very secondary consideration in terms of performance or how well it worked. But as we have seen over the years, These days, tracing and logging is very much something that we need to make sure runs as fast and as efficient as possible. Which leads me to my motivation for all of this. So, I mean, a couple of years back, Searle started this war on non-determinism when trying to understand why certain problems, and I'm thinking specifically about the J9 project here, why certain problems were not very reproducible at all. And these problems were made even more irreproducible when you turned on tracing and logging. And in fact, they would completely go into remission in many cases. And we still have that situation today, where you may have gotten um, a test to get down to a point where you can reproduce it 100% of the time, but when you try to finally get that log of that method, you're unsuccessful. And there are reasons for that, and we'd like to understand some of those reasons. But a couple of years back, I started looking into this problem deeply, and one of the first things that discovered was how much of a resource hog the tracing and logging is, to the point where it was consuming so much of the resources that it was taking away from the actual compilation itself. So the actual compile that it was doing would look different when tracing and logging was enabled than when it wasn't. And there were a number of problems that I had found with the memory utilization. We were just using gobs and gobs of memory for doing very simple operations. And it was clear that when somebody wrote the code, some of that code, it would, it looked fine on its own. But if you're I can't remember the exact case from a couple years ago, but there was some code for printing out a constant, um, and we were consuming about 74 bytes of memory on the stack every time, and we had some kind of a recursive descent with this, and it was just consuming ridiculous amounts of memory just to do a simple printing out a simple constant. So a lot of those memory problems I addressed, and I committed some code to knock them down. There are still many places where we are consuming a lot of resources, but I got a lot of the low-hanging fruit a couple of years back. There's more to do there, but another part of the problem that was seen was just the path length of the code that we have with when tracing and logging is enabled, and how many steps it takes to output a single character to the log file, and the overheads that is causing. So my main motivation for starting to look at improving this stuff was problem reproducibility, and to try to rein in some of that, and to bring the default mode closer to where, or sorry, to bring the modes where tracing and logging is enabled closer to what the default mode is. Another motivation here is that I want to make sure that the tracing and logging infrastructure that we have is actually providing the right kinds of tools and interfaces that are needed to solve and investigate the problems that we're trying to investigate. One of the things, you may have discovered this yourself, but I certainly saw this as I was exhaustively looking at this code, was that a lot of the tracing and logging functions that we have make certain assumptions about what they're going to do with that logging information, right? So for example, a certain function you can't call because it expects that it's going to get the log file from the compilation object. There's no way of you passing in a different log file or some other kinds of information in order for it to deal with that. It's making very specific assumptions about where this information is expected to go. So want to understand what those are and see where we might be remiss, and what new features might be possible to help with people debugging. And I said this is 25 years old. There's a lot of technical debt in that code. I'll show I have a slide a little bit later that shows the different ways that we have for doing different kinds of tracing and logging, but there's a lot there. The code really does need to be cleaned up. simplified, and documentation is lacking in a number of places as well. We also have examples of APIs that were well used, 20 years ago, but are no longer really useful anymore. So we should really just get rid of those and migrate whatever information that they're recording into something else, something that is being more actively used. So that's what was lighting the fire under me to look at this. What are some of the things that I think that we should be trying to do here? So first off, just reducing the compile time overheads when tracing and logging is enabled. So what that effectively means is that when you have a piece of information that you want to output somewhere, the path length to output that data should be as short as possible. You need to get that thing printed as fast as you can, and not consume a lot of path length or memory on the way out. And that's actually what the second bullet here is about the resource consumption. So some of the operations that we do to output diagnostic information use a lot of memory. And in many cases as well, we are producing an awful lot of data to say something that could be said much simpler. I'm not going to talk about the fact that we are producing formatted logs here. That's maybe a topic for another time, but and probably a future topic. But I think there are ways that we can output things a lot more concisely than we are, and that'll certainly save time and memory going forward. Just as a quick example of how much time it takes to, like the difference, just to give you a bit of a perspective between how long it takes to compile something with tracing enabled versus not. This is just a completely brain dead sort of difference between scorching at count 0 with full tracing enabled with just Java version versus not. And on average, it takes about 7.5 to 8 times longer to compile every single method when you've got tracing enabled. But for about a quarter of the methods, maybe even almost a third of the methods, they take much longer than that, somewhere between 10 and 160 times longer to compile and for the compile to complete when you've got tracing enabled. And there's various reasons for that. If you haven't looked at this recently, I'll give you a quick tour down through what J9 does to print a single character to the log file. So you will see in many places we have trf printf to some output file, and you've got the new line character. And for that operation to occur involves many different function calls. It involves allocating data structures that are not even used. Sometimes they are, approaching a kilobyte in length. And we do a lot of operations here, even though they're not required. So for example, treating this as if it had format specifiers and going through all the effort to process the format specifier when there isn't one here. Before eventually writing out the character into the C runtime. What I don't show here is all the logic that's happening within some of these functions. These are just the function calls themselves, but some of the logic that's happening to figure out what the next step is going to be. So I didn't count instructions here. Maybe I should have done some creative thing to figure out how many machine cycles are taken to make sure that /n gets written to the buffer, but it is quite extensive here. The other thing that I'd like to do as well is to standardize the tracing and logging API. We have a number of different means at our disposal for outputting for writing diagnostic information. I think it's definitely worth our while to have a simplified document and fast API for doing just that. Takes the guesswork out of things, and it really just, it gives us a single point where we can make improvements as well going forward. If you look through the code right now, there's a lot of different APIs that are in use. There's the diagnostic macro, which was really the thing that we were using 25 years ago. It's still around in the code, but it's only available for debug builds, and debug builds aren't things that we do typically anymore. So a lot of those diagnostic type macro diagnostic information is not really being outputted at all. Trace message is quite common. It's used quite a bit in the optimizer and some of the common code. Its claim to fame here is that it does do a check to see, and we can talk about this in a sec, but it does do a check to see whether or not the debug object is loaded. And if the debug object is loaded, then it'll go ahead and perform the output the appropriate trace message. We don't actually have a separate shared object anymore, but we still have a debug object that we must allocate, and it only gets allocated when certain tracing and logging options are provided on the command line. Ultimately, I think that trace message calls down to tr debug trace, but you'll see some raw calls to trace itself throughout the code as well. Perform transformation. This is a one that will also do some tracing, but it also is one that will only do a transformation if it basically counts how many transformations have been done, and if you're within a certain range, it'll do the transformation. Otherwise, it'll skip it. So this is useful for debugging. So if you've used like last opt index, first opt index, this is where that's feeding into. We also have dumped opt details, trace opt details macros that sort of map down to some of those things. And then you'll see that, and this is more common in the backends, and some of the ancillary code, raw calls to trfprintf, and even trio will call fprintf. So there's the number of places that are using that. And then more rarely, but more frequent than I would have expected to see, there are actually raw calls directly to the C runtime or C++ runtime. So fprintfs, and more frighteningly, printfs are in the code as well. That'll go directly to standard out. So, but those are still there. I mean, I think most of those are, if not all of them, are guarded in some way, which is good. But really, it's it's not a story that I think that we should be using. So what I'd like to see here is that a lot of these get blended together and sort of standardized into a single API that and a set of tools that can be used to perform tracing and logging. When it comes to investigating problems, and particularly challenging problems, you often have to you have to think on your feet, and you can't just use the debugging features that are available in the way that somebody else has decided that you should use them. In many cases, you're in a certain place in the code and you know that I need to dump this particular data structure at this moment in time to get the information that I want, or I need to dump the trees right here so that I can get a very crisp idea as to what's going to happen next. Unfortunately, the way that some of our functions are written, it doesn't really allow this, right? It really expects that they're only going to be used in certain contexts. It only expects that it's going to use with a certain log file, and it knows where to look for the log file for that. So you can't do things like, actually, I want you to write into this different file altogether. I want to separate this information from other information, right? So what we really need to do here to enable this kind of creative debugging is to parameterize a lot of the tracing and logging functions to accept the destination. So right now, many of these accept a tr : file, which is a file pointer a Testarossa file pointer of all things to a to the log file. But not everything accepts that. And I think there's an opportunity here for us to make that a little bit more ubiquitous in a lot of these APIs. This will also allow us to have different logging alternatives to just straight file I/O. So, for example, and I know that we've hacked this in the past, and it doesn't happen that often, but we have hacked this, right? Where we've had to write the tracing information on a network socket. We couldn't write to a file. We had to send it somewhere else. So some hacking and creativity was involved to get that to happen, but yeah, but with a better scheme in place, it should be much easier to allow that sort of thing to happen. And similarly, you could actually replace the logging destination with some kind of a debug facility to catch trace messages that are unguarded, right? Right now, you look at the log file, like I said before, you see a lot of stuff in there that's obviously not guarded by any sort of tracing. You could install a logging destination that essentially asserts and produces a backtrace when it sees that you're trying to output something that is unguarded, and we can use that as part of our testing, for example, to uncover these sorts of things that need to get fixed and where to fix them. And the other thing that I think that should happen here is that I'd like to instill some best practices for developers when they are implementing diagnostic features for their code that they're writing, and the way that they use the tracing and logging infrastructure. So, like I said before, we need to get to this mindset that performance of tracing and logging is particularly important, and our success at investigating problems is often tied to how efficient those paths actually are. So we really do need to give, when we're writing tracing and logging code, making sure that they're written with performance and footprint in mind so that we don't disturb, we're good citizens, we're not disturbing the rest of the compilation and perhaps causing different behavior. Also using the established APIs just for consistency, right? I mean, right now we've got, like I said, we've got about 5 or 6 different ways of producing tracing and logging code. But really, if we all use the same API for this, if everybody understood what it was and how it worked, then we'd be a lot more consistent, and I think some of this outputs would be more useful. And avoiding redundancy is another sort of important best practice that we want to get in place here. So don't just output something for the sake of outputting something. Make sure that it's actually useful data and it's as small as and concise as it can possibly be, so that when it does eventually get into a log file, we're not incurring too much of an overhead in producing that. So and if you have to produce a lot of data, which there are good reasons for that, make sure that there are options in place to control that. So some of these, we've got some of these best practices, being observed throughout the code, but I think that we just need to make them a little bit more consistent going forward. So that's sort of a secondary benefit to what I'm talking about here, and it's maybe a longer term thing, maybe even as part of technical debt sort of cleanup, but it is an important thing that needs to get we need to work on. So that leads into maybe a proposal as to what we can possibly do here. So essentially, one of the things that we should be doing here is just replacing TR file as the currency for all the tracing and loggings. And what I think we could replace that with is sort of an abstract class, just calling it a logger class, that essentially represents what you want to do with the diagnostic information that you're writing out, right? So it's not just a destination, it's really more of a class that's got various members in it that can perform I/O operations of some sort. So it doesn't really matter what you're actually produced, like how the logger is actually implemented. As long as it's following this API, you're going to get sort of the behavior that you're expecting. So in this particular example here, I just happen to have um, the sort of the essential I/O functions that you would expect to write things out. But it does provide so like the printfs for the formatted strings, but it does provide optimizations for the faster for more expedient output. So for example, things like print s for a constant string that doesn't have any format specifiers in it. Or if you're outputting a single character, there's a faster way of getting that character out the door. And we see this all over the code. We've got a lot of printfs of just /n all over the place. If we have a more expedient way of getting that out the door, then here's a function for you. One of the things that we have as well with printf is that in Testarossa we do our own interpolation of the format specifier. And what we're looking for is %ps, because we have a mode that, if you weren't aware of this, we have a mode called mask addresses, which was implemented, I don't know how many years ago, to aid comparing two different logs with each other. And what it's intended to do is to mask out the address, like actually, rather than having an actual virtual address in there, it would have just some sort of a constant to indicate that this is the nth address that it's outputting. And that way, when you did a diff of two different logs that were just subtly different, that wouldn't show up as a difference between them. Unfortunately, I mean, that was the grand plan. Unfortunately, that code has been long neglected, and not everything goes through that interpolation path. Like we don't use %p to print out all our addresses, for example, and we haven't done that in quite some time. So it's a very inconsistent utilization of that. So, however, there is a function here in this API, trprintf. If you really wanted to go through that interpolation path, it's there. We should talk at some point about whether or not we want masked addresses going forward, because if we do, then there's going to be a fair bit of work to make it work consistently. But that's maybe a topic for another time. So that's essentially what the API, just a minimal API, would look like in a base class. And just to see how it would actually be used in practice here, you replace the file parameter in print for the VV constraints with a logger, and then you call the various functions throughout here for whatever you want. So as an example of print s, print f, I got a print c down here as well. So just as you would expect. So what this base class really does, it doesn't really do anything on its own. It is like an abstract base class, but you do have to provide. It does allow you to define loggers that have got various implementations to do different things, right? So, for example, you could have a streaming logger that's based on the C runtime, right? All those functions do is map directly out the door to a C runtime method, right? So you call log printf, that's just going to call printf under the covers, right out the door. You could do the same thing if you wanted to be backed by the port lib. You could, instead of calling the C runtime, you could call the corresponding port library method. Right now we have a TRIO class that does that check every time you print. It checks to see, should this go to the port library or should it go to the C runtime? And by default, I think by default, it's going to the C runtime, but still we're going through this check for every single thing that you print. You could have the notion of a synchronized logger where you get the behavior similar to what the verbose log does. So the verbose log is synchronized in the sense that we don't want multiple compilation threads to be writing to it at the same time, so that you get information overwriting each other in the log. You want to make sure that I have an atomic piece of information that I want to write in the log file. And so it grabs the lock, does the write, flushes it, and makes sure that it gets there consistently. So you could easily do that sort of thing with a logger implementation as well, right? Socket logger, talked about that already, and like a debugging kind of logger as well. There's other sorts of things you can do. I've experimented with like a buffering logger as well to see if I could get better performance out of the writing that way. So rather than doing writes every 4 kilobytes, which is what I think the C runtime does, you can buffer these things up into like 1 megabyte chunks, for example, and then blast the whole thing out the door when you've got that. Um, so this does use virtual functions though, but the overhead of that is actually comparable to the way that we're currently doing it, like currently calling, let's say, a trfprintf, mainly because trfprintf is not actually a function itself, but it's a function pointer, which points to something into the trio class. So it's giving you the same kind of performance overhead it's an indirect call essentially. So it's giving you the same kind of performance, but you're getting a lot more flexibility with it. You can use the default logger that would be available via the compilation through an API. So kind of like you ask for a log file right now through the compilation object. But one of the differences here is that there will always be a logger available, even if you haven't provided one on your own. And the default logger could very well be standard out. And one of the advantages of that is that you don't have to continuously check, which is what we currently do, to see whether or not someone has actually installed a logger. Sometimes you're very deep in the code where you have no business being in that code unless you've already got a log file in hand. Yet we continually check, do we still have a log? Like, do we have a log file? Do we have a log file before we output anything? So by default, we can have a standard out one that'll always be available, knowing that you're not going to crash if you happen to write to a logger that's not guarded, for example. It's very easy to create. It should be easy to create a new logger as well. With a very simple API. And talked a bit about verbose logging. The focus here is really on the diagnostic tracing and logging as opposed to the compilation reporting, which is what you'd see in verbose logging. But I didn't want any sort of design to preclude using this in other areas where we are doing tracing and logging as well, so that maybe eventually someday we could leverage this as well to implement some of the verbose logging if we choose. So what to do here? So there's a lot to do here. If you ever looked at this code, it's really spread out all over the place. What wanted to do is to kind of get the code in better shape than it is right now, to establish like a consistent, flexible approach that is more closer to what we want it to be. And once we're there, we can then start to do some of the further tracing and logging improvements. But it's really just kind of making things a lot more consistent than they currently are, and giving us the baseline, the foundation that we can use to start building more things on top of this. The idea is to start in OMR because a lot of the tracing and logging stuff lives in OMR, but changing some of the APIs may break some of the downstream projects. Some of the APIs we could maybe dual maintain. We could have the original file API and we could have a logger API, but some of those changes may not be possible. But if they aren't possible, we may need to do coordinated merges if we need to get these changes in together. So standardized tracing APIs to pass in the logger as the first parameter. So right now, we do pass around TR files, but not every API accepts them, and not every API accepts it as the first parameter. So it's somewhere within the argument list. So it's not a very it's not a very consistent API. So the idea here is to change the various tracing and logging APIs to add the logger if it doesn't exist, and then change the parameters so that it appears first. Um, there are many places in the code that are outputting basically just constant strings or single characters or new lines. There's opportunities to use the more path length friendly versions of those for outputting that. And for printfs that use %p in them, we can replace those with trf printf so that we get the similar behavior as to what we're getting right now with the address masking. But I think we should give some serious consideration as to whether or not this feature is even useful anymore, and to perhaps just get rid of it entirely. I think I might be leaning in that direction. The diff tools that are available now are much more powerful than they were, say, 20 years ago, and they can even be taught to ignore address differences in two different logs, for example. So this isn't a problem that necessarily needs to get solved by the JIT. It can be solved by downstream tools that are consuming logs. So maybe this isn't, we don't bring in all this extra complexity that we currently have. And then the other thing here is start working toward an implementation that relies on checking whether tracing is enabled before proceeding. Oh yeah. So what that essentially is saying is that again, if you look at this code, there's often a couple of different things that get checked. One is whether or not there's a debug object around, and secondly, whether or not the file pointer is null or not. And we do those checks all over the place. And again, there could be places, and there's places in the code where if you're ever that deep into the code, you should not be checking this stuff anymore. You would have to know that. And in fact, that isn't really even the right way to check to see whether or not you should be doing tracing and logging, whether or not this debug object is around or not. So really like to get to the point where all you really need to check at some point is whether or not tracing is enabled, and then go ahead and do that tracing before proceeding. So, all right, so I got one more slide, and this is more of a future directions, not necessarily related to this specific kind of tracing and logging, but other things that I think do need some attention related to diagnosing problems. So first idea here is really just to make some refinements to enable and disable tree dumps at various points. We just need to make sure that we have the right amount of data being written to the log, because at some points it's just way too voluminous. We already do some things to try and mitigate that. Like, for example, we won't output trees after each optimization if that optimization didn't actually do anything. But those kinds of things should be, that kind of thing should be replicated like in the code generator, which tends to dump everything out that all the time. So that needs to get fixed up. Just reducing the noise that's coming out, especially if it's not really needed. I've talked about the debug object. If you've never looked at the code before, you'll see that we have apparently a very bizarre way of representing code, that some of the tracing and logging code, in that it's hidden behind a tr_debug object. If you don't know the history, the reason we did it that way was many years ago, maybe even 20 years ago. And the reason we did that was because we have an embedded heritage with J9, and the idea there was that footprint, even the shared object footprint, was very important. So we tried to get that down to be as small as we possibly could. And one of the bigger areas that we could find that consumed a lot of the space were the RAS features. So what ended up happening was we moved all of the tracing and logging and debugging and all that code into behind an interface, behind an API, and we could actually offload that entirely into its own shared object. So only if somebody really needed to debug something and they really needed those functions, then they would load that separate shared object. So it was really sort of a savings that way. That went away a long time ago, but unfortunately, the notion of the debug object stuck around, in part because it's a lot of work to get rid of it and just to do all that refactoring. But it looks a bit unusual, and it is. But I think going forward, we need to figure out whether or not that kind of separation is still warranted, because if it is, we don't want to undo a lot of the work that's already been done to make that separation, because we're probably closer to maybe resurrecting a separate shared object than we would be to removing all of the um, uh, refactoring that we had done to support it. Um, I've also got explore low overhead JIT state dumps for offline processing. So what that means is um, that the JIT shouldn't necessarily be in the business of producing a formatted trace file. It takes a lot of computational effort, as you see, to output some of the information. And it might be better if we just, in some cases, just raw dumped a bunch of stuff out and then processed it offline after the application is or so that you don't interfere with the JIT operation. You just get the information out as fast as possible. And we'd experimented with this in the past. There aren't we haven't gone too far with that, but there are potentially ways of minimizing the amount of information that gets written out without so much formatting, just so that we can get the data out quicker and not to interfere with things. So I think that there's some ideas that we can explore in that space going forward, but I don't think that that's something that's really on the front burner at this point just yet. Um, regex processing. Um, so this is actually something so we have our own regex processor in the JIT, if you haven't seen it. It was actually worked on. We actually did have an original one that was already overhauled to improve its performance. But I think in the 20 plus years that we've been using that, I think there are some opportunities for improving even that to make things a bit quicker. So that is something that could be looked at in the future for reducing the overhead related to debugging here. And then everyone's favorite topic is a TR options overhaul. We've had discussions on this in the past. We even have, like Nazim even has a prototype in OMR for how we want to do something like that going forward. I think at some point we want to blow the dust out of this kind of a topic and figure out the best way of doing things. I know Irwin also has a PR in the OpenJ9 repo active right now, or is it just an issue? I think it's a PR to basically move in some of the to do some of the refactoring that is needed and move some of the J9 specific bits into J9 rather than relying on OMR to do that. So those are steps in the right direction, but I think that really this needs a fairly good overhaul as well. But again, beyond the scope of what I wanted to talk about today. So yeah, so the main thing I wanted to just convey here was just some of the thinking that I wanted to do around refactoring the tracing and logging code to make it a bit more to introduce the notion of a logger and to get some of that code in place and start to move forward with that. I'm certainly willing to hear any thoughts or opinions people have on that, if it's a terrible idea or what have you. I will say that with the minimal amount of effort that I've put into it so far and just the platforms that I've tested it on, performance just of the little bits that I've done has improved already by about 20% by just changing I think it would be just by reducing those path lengths by changing the printing the strings, printing the characters, just avoiding some of that overhead, removing the checks for null out files, all that sort of thing. So it's been a positive experience so far, but I certainly think there's a lot more low-hanging fruit there to get. And obviously, if we continue on this path, there's even more impactful things that could be done as well. So anyway, I've blathered on here for almost 50 minutes. I think I'll stop here and cross my fingers I wasn't on mute and open it up to any discussion that people want to have here.
Well, I have a kind of a bunch of questions, so I guess I'll just start and then see. How does this interact with perform transformation and dump opt details?
So it doesn't right now. This is sort of I didn't get into the details of perform transformation just yet, or even the dump op details. This is all the other ancillary stuff to that. So I don't have a great answer on that right now. I'll have to dive into that.
Okay. Let's see. So by default, you were saying that we could log to standard out, but could we discard output instead? Because I don't know.
Yeah, you could eat it. Yeah.
That sounds really scary to me. Standard out by default.
Yeah, you could certainly eat it. Yeah. I would think that we would have a testing mode, like prior to testing mode that would install like a debug kind of logger that would catch those kinds of things and all the various tests that we would run.
Yeah, I like the idea of the debug logger. It's just that if something is missed, that's effectively you have the printf to standard out.
Yeah, frighteningly, we already have raw printfs in the code. I think in most cases, all cases, they're guarded, but if people are actually using those for debugging and they stay in the code, we could be in for some surprises. I think we did have a problem like that a few years ago, where a message was output that wasn't expected. But yeah, it's a good idea.
And well, here I think I only actually have one other thing here that I think is important, which is the OMR formatting versus standard library formatting. That I don't believe that should be changeable, like by swapping out the implementation. The fact that both are possible right now is a problem, and it's a problem because the format specifiers are not.
So just to clarify,
they don't necessarily mean the same thing.
Yeah. So just to clarify what you mean the right now for the format specifiers in OMR, we use OMR underscore PRIX, for example, versus the ones that you'd find in the C standard library.
Yeah. So there was. I thought you were mentioning about like there's a OMR, sprintf effectively, versus calling the standard library, C standard library.
Oh no, I think what I meant by that was that there's one that calls the port library to do the printing versus calling the C runtime to do the printing.
Yes, exactly. That's what I'm talking about. So the port library, that's the OMR thing.
Okay. And you're saying that the format specifiers may be different. Okay.
They are different.
Yeah.
Or well, a lot of them are the same, but they don't have the same meaning, right? The OMR ones are chosen to have the same size regardless of platform. But the actual ones that are in in the standard library, they vary um, based on the platform that you're on. So uh, it shouldn't behave one way or another depending on which logger happens to be installed. And right now, that shouldn't be conditional. We should know how they're going to be interpreted everywhere where we write a format string.
Yeah. Yeah, so that's something we should probably have fixed now, but yeah, you're right. That should be, yeah, we should fix that.
It's uh, it's pretty difficult to print. I think a 64-bit integer, or just it's it, there are just going to be cases where it's or a pointer sized integer. If you want to print a pointer sized integer, I think that could. I don't remember the details, but the last time I looked at this, I was going, "How do I print this?" And I go, "Oh wow, it can happen this way, or it can happen that way." And how do I make sure that it works no matter what? And I'm not sure that there even was a way. It was just a nightmare. So
Yeah, we had an issue a couple of years, more than a couple of years ago. It wasn't a problem, but the issue was that even percent %P was not behaving similarly across different compilers. And in some cases, we were getting like capitalized. Sometimes it had the 0x in front of it, and sometimes it didn't. And we were wondering if we could standardize on that. So there are some issues that we think we have with uh, pointer printing that could hopefully be improved.
sure, it's just as um, I'm not too worried personally about consistency of the output that you get on one platform versus another platform, as long as it's readable. But um, just as long as whatever it is that we choose to do is consistent, and we know that uh, this thing expects say if I'm passing a int 64 or whatever, we're not going to get mixed up about what the size of something is, how many argument stack slots does that eat, uh, and so
Yeah.
on.
Okay. Yeah. Thanks for pointing that out, Devin. That's good. Any other comments?
Just from another downstream project, I think that this sounds like a really good idea. I like the look of where this is going, so I'm with you.
Thanks, Kevin.
Yep.
I guess I'll add that I do like the idea of removing the address masking.
Great.
I would be surprised if anyone has turned on that option for a lot of years. So
Yeah,
I
I
should say,
remember the. Go ahead.
I was just going to say I didn't know that option existed actually, but I have a little tool that we use locally for the same purpose that works fine enough for masking addresses in our logs to compare them. So
yeah, whenever I need to do that, I just kind of use a search and replace in Vim.
yeah, basically, I've got a little Python script that does something similar.
Okay. So, I mean, don't expect a PR anytime soon on this. I have a branch that I've been tinkering with in the background, like I said, but if something does surface, like over the holidays, for example, don't be overly shocked. Um, any other discussion on this? If not, then one thing I just wanted to mention was that Kevin pointed out the other day that I did not create a branch for the 0.30 release, which I intended to do, but I didn't. So I'm going to work on that after the call here today, so this we get that in place. And with that, and if there's no other questions, thank you for your time this week, and we will convene again in 2 weeks. Thanks, everyone.
Thanks, Daryl. Thanks, everybody.